Hello, my name is Cojanu Vlad, and today I will present you my research intitulated Consideration of the Efficient Functioning of Urban Water Pumping Station. This research was made with the help of Professor Helerea. Today's presentation will be about drinking water and urban water supply system, centrifugal pumps. Then I will present you our case study and we'll have some conclusions. Drinking water and urban water supply system. The urban water supply system is an hydraulical system that has the role to supply, transport and distribute water to consumers in an urban area. Its main components are the source, which can be a groundwater source or a surface water source, the water treatment area where the water is being carefully treated to become drinking water, the storage area, the distribution network, which in my opinion is the most complex part of the system because it has a lot of junctions and it's very vast, and also the measuring command and control points. Here you can see two types of water supply systems. The first, in the first figure, you can see a simple water supply system. You can identify the groundwater source. You have the pumping stations, the water storage, and the consumers. This type of system is very similar with the system that we have taken consideration for our case study. The second image, the second figure, you see a more complex urban water supply system. We have two water sources, a surface water source that is being treated in the treatment plant, a groundwater source, you have the consumers, the main storage, you have a secondary storage, and also you have some pumping stations. Centrifugal pumps. A centrifugal pump is a turbo machine that is capable of transporting the liquid by raising its specific volume flow to a specific pressure level. In figure 3 you can see a simple centrifugal pump section and you can identify its main components. First is the suction side, or also the inlet, it's called inlet. And on the other side is the pressure side, also the outlet. Between the suction side and the pressure side you have the impeller, which is with red. Also you can identify the pump casing, the pipe flange, which connects to which helps connecting to the system, and also you have the drive shaft, which is connecting the pump to an electrical source in most of the cases. In terms of energy per pumping fluid, to see the relationship between a pump and the system, we will use the Bernoulli equation, which you can see. And here you can identify the first part as the energy input, yes, and the second part as the energy output. Also, you can identify the hydraulical energy and the hydraulical power. The relations, the mathematical relations are very similar. In the hydraulical energy, when we calculate, we use the volume, and in the hydraulical power of the pump, when we calculate it, we use the flow. This is the main difference. Yes. And here also we have the density, the acceleration, the gravitational acceleration, and the head of the pump. Also, in the last formula, you can see the pump efficiency. In our case study, we take in consideration a part of the urban water supply system of Brașov, which serves an area of about 40 hectares. In this particularly part of the urban water supply system of Brașov, there are being used pumps to deliver the water to the consumers. This area that we have been studying was an industrial area, and now it's being transformed to a living area and also an office area. The main objectives of our analysis is the water consumption and the electrical energy used to power the pumps in this area, and we try to establish an efficiency coefficient for the system that we have studied. Here you can see the pumps. The pumps that are used in this system are centrifugal pumps with multiple stages. They have a nominal flow of 64 cubic meters. Also, they have a maximum pumping height of over 70 meters, and the maximum pressure is about 16 bars. This centrifugal pump is being driven by an electrical motor, which has a rated power of 15 kilowatts. It is an electrical power that is very efficient. It has an energy efficiency above 90% in 3 cases that are shown at maximum load, at half load, and at 75 percent of load. Also, the electrical motor is a 3-phase asynchronous motor, and the pump has more stages. How you can see here in a section of the pump. This is the motor. We have the coupling of the motor and the shaft. Also, you can see here the shaft and the seals. You have the impellers, the base of the pump. You have the inlet, the outlet, the pump head. This is a very simple hydraulical scheme of the system. You have here the pumps, you have the water source, you have 2 areas of storage, the water, and then the water goes to the consumer. The electricity comes from the national electrical system, and also the pumps are being can be used with the help of a generator if we have problems with the electricity from the national system. The case study, we measure hourly in the January 2020. We have more than 700 measures. Here you can see two charts. The first one is with the daily electrical consumption, and the other one is with daily electrical flow. Yes, the general form of the chart is the same, because the electrical consumption and the daily flow consumption are the same. Yes, they are uh, they have similar values. One here in the first graph you can see the minimum and the maximum, yeah, also in the second graph. And about the minimum and the maximum energy consumption, we have the first, we will discuss about hourly consumption. The minimum hourly consumption we have seen that are in the morning around 5 in the morning mostly, but also at 3 or 1 in the morning. And the minimum consumption is about 15 kilowatts hour. The maximum consumption, on the other hand, was 21 kilowatt hour in 8 January, 9 January, and in 20 January. You can see that the maximum consumption is around 21, yeah, and also on 22 in a case. When we look at the daily consumption, the minimum daily consumption is the 1st January, and the maximum consumption is in 9 January. You will see that the minimum daily consumption is in the 1st January, but the minimum hourly consumption is not in the 1st January, which is very interesting. About the energy efficiency index of the pump, we have calculated, and it's around class D in our case, which is not either bad, either good. It should go upward. In conclusion, the study in the whole period that we have been studied, for every cubic meter that was delivered to the consumer, it had been used 0.63 kilowatt hours. After the analyzing of the hourly consumption, we have seen that the peak consumption is around 21-23, and the least consumption is around 3-5 in the morning. And from this type of behavior, we see that the most consumers are the domestic ones. In order to increase the pump efficiency in the future, we propose to operate the pumps according to a well-established schedule to decrease the hydraulical losses from the intake and the discharge of the pipes, and to regularly maintain and replace the worn parts. Thank you for your attention.